सौराष्ट्र विद्यापीठ सदाए पावनकारी नाम, दरिया जेवी घूघवे अहिया जग विद्या तमाम।
सौराष्ट्र विद्यापीठ सदाए पावनकारी नाम, दरिया जेवी घूघवे अहिया जग विद्या तमाम।
जय हो जय हो जय जयकार, जय हो जय हो जय जयकार।
Good morning, everybody present in this webinar, which is jointly organized by Saurashtra University Department of Physics and Gujarat Science Academy, along with Essencetech. Now, before starting our session, we have a special guest. So I would like to first of all invite Professor Dr. Hiren Joshi, sir, the senior professor in the Department of Physics, to please introduce our guest. I welcome Dr. Hiren, sir. Please, sir.
We are really fortunate that we have with us Professor Pratapsinh Chauhan as our special guest. Professor Pratapsinh Chauhan, sir, Honorable Vice Chancellor of Shri Govind Guru University, Gujarat. Sir, Jai Swaminarayan. We heartily welcome you on this webinar, Anusandhan, and we are very grateful that you spared your valuable time to join us. It is my pleasant duty to give a brief introduction of Professor Pratapsinhji, our invited guest, to the participants. Professor Pratapsinh Chauhan, before joining as a Vice Chancellor of Govind Guru University, Gujarat, he was a Vice Chancellor of Saurashtra University for 3 years during 2015 to 18. He has a very keen interest in science and imbibing scientific temper in the students. The vast administrative experience at very high policy making level in various committees. He is a syndicate member of Saurashtra University, also served as a Dean, Faculty of Management, Head of MBA Department, etc. He has worked as a NAC Executive Committee member, member of Academic Advisory Council, CEC New Delhi, and UGC Planning Committee, and member of Expert Committee for Evaluation of various funding agencies. Professor Pratapsinh, rare quality, that is what I have observed myself. In case of Pratapsinhji, his administrative knack and academic excellence goes hand in hand, which is really a rare quality. As an administrator, he is very considerate and humanitarian with a kind heart. Professor Pratapsinh is an expert person of finance and management. He has very reputed research papers and awards to his credit, and guided more than 60 doctoral students and made numerous foreign trips for delivering expert talks in various conferences. Sir, once again I welcome you and thank Professor Pratapsinhji Chauhan for joining with us on this webinar, Anusandhan. Thank you very much, sir. Welcome you, sir.
Thank you. Thank you. Now is audible, Hadit?
Yes, sir. Yes, sir. Yes, sir, you are audible.
So, my dear friend, Professor Hiren Joshi has given me the opportunity. Professor Nikesh Shah and his team is working very hard to organize a webinar on research methodology and frontier in the science. Dear friend, this is the lockdown period. We are come across and suffering a lot of difficulties. all over the world, they're facing many difficulties. But now the higher education institution and role of the university is a very different mode. And at that time, the physics department team, Professor Nikesh Shah and his team, has today organized the webinar on research methodology and frontier in the science. Here, they have informed me very close to 450 delegates from the different branch of knowledge, and basically is dominated by the physics and science affinity. Dear friend, this is the time where we can, in the last 33 days in the lockdown at 2, we are at home and working from the home. As a management expert, and within this 33 days, we have, I have also, the right a Gita application in management, the modern management, and I have, completed my 100 pages first part of the my books. So it is a time, the once in your own life, we can get the time. But at the same time, the country is facing a problem. Day by day, the COVID-19, the cases is increased. And for that, how science people, the pure science, the whole country, our policymaker, administrator, is depend on the pure science. And physics, biology, and chemistry, these are the, the major group where the pure scientists are working together and find out for country to, a feasible solution. And so far as the cost is concerned, we are, in the country where the 1.3 billion people are there. And that's why anything you have to search, innovation or invention, that will be very easy to operate. The cost will be very low. And that's why this webinar, research methodology, is a very, very useful part, because the many students I have come across in my faculty, the initial stage, they do not know how to use a methodology, what are the tools and techniques it is used to identify our issues concerned to the title or a problem. My dear friend, 450 people are, the getting at home the knowledge sharing from the expert. The many, the Professor Hiren Joshi, the very senior professor and the physics department, the Professor Head Mihir Bhai Joshi is there under the, the leadership and guidance of the two senior faculty members, because I have worked with the physics department. Many times at night, I visited the physics department, how the research scholar is working in the physics department. And now the young people, the Nikesh Shah and the team is leading to the university, and particularly in the physics department. So my best wishes, because I am not a person of the science, but I know the science and technology, if India is contribute in the after the post COVID-19, we have a lot of opportunity, business opportunity, but the basic issue is we need a good scientist, good researcher, where we can develop our own commercial product. We are not depend on the outside. And yesterday, our Honorable Prime Minister had said, the self-reliance is the need of the day. The self-reliance means what? We cannot, depend on the PPE kit or any equipments from the outside. And what is our experience? The rapid test, it is also not useful. And that's why our scientists, researchers come forward, find out the feasible solution, and that will be useful to the country. So my best wishes to all the participants, all the speaker, professor, and the organizer, the Nikesh Shah and Hardik Bhai and Piyush Bhai, all you young dynamic teacher in the physics department, they can manage well because at very a less cost, we organize the webinar and particular area is research methodology. What are the tools and techniques? What are the difficulties facing by the researcher? And where we can help to our a new and young researcher in a particular subject area, that is a research methodology. I am thankful to Professor Nikesh Shah, Mihir Bhai and Hiren Bhai, given me an opportunity to express my feeling in the front of the all delegates. So once again, thank you very much. Bharat Mata Ki Jai.
Thank you so much.
Hello.
Thank you so much. Thank you so much, Pratap sir, for gracing this event by your presence and by your kind address. Thank you so much, sir. Thank you very much.
So
Thank
kind
you.
of you. Wish you all the best.
Thank you so
Thank you,
much,
sir.
sir. Now we will move to the next part of our session. And to introduce our today's speaker, I would like to invite Dr. Tushar Pandya, sir, for the introduction of our today's speaker. Yes, welcome, sir.
Thank you, Chintan. Good morning, dignitaries online. Good morning to all. It gives me immense pleasure to introduce our dynamic fellow of Gujarat Science Academy, Professor Mahesh Thakkar. Dear friends, Professor Mahesh Thakkar is a professor of geology and head of the Earth and Environmental Science of Kachchh University. Dear participants, he is regarded as a scholar, geologist, and expert in quaternary geology. Friends, during the period of December 1991 to July 2008, he was a faculty member of Shri R.R. Lalan's College of Bhuj. He served as a principal at Lalan College during the period of June 2006 to June 2008. Dear friends, he joined the Kachchh University as a professor in the year of July 2008. Friends, Professor Thakkar is having 30 years of teaching experience along with a vast field experience in geology. And during this 30 years, he has established himself as an excellent teacher and a pioneer research in geology. Friends, his area of research are quaternary tectonics, paleoclimates, and paleoseismology. His more than 16 research papers are published in a peer-reviewed reputed journals of geology, and more than 5 students have been awarded PhD degree under his supervision. He has completed many DST research projects as a principal investigator and participated in many international and national conferences. My dear friends, Professor Thakkar has authored two important books in geology, which has been published by Indian Institute of Geomorphologists, Allahabad, and Kachchh University. Friends, he has translated geology terminology in Gujarati and Hindi, and his 7 volumes of books are published by Gujarat Granth Nirman Board. Friends, I'm very happy to inform you that in the year of 2013, he was awarded as an international award for Best Raghuvanshi Shodh Sanshodhak Award. Congratulations, Thakkar sir.
Thank you, sir.
Professor Thakkar is also a popular science writer and has contributed many articles on earthquakes in the scientific magazine and newspaper. He has given many public lectures, newspaper articles, TV appearances for the popularization of geology and outreach activity in science. A friend, besides his engagement in all these academic activities, Professor Thakkar has also worked as the Dean of Science Faculty of Kachchh University. He served as a in-charge registrar of Kachchh University. He was a chairman of Board of Studies and district coordinator for the quality enhancement in higher education. He has worked as a convener and conducted many workshops, seminars, conferences, symposium. Sir, I take the opportunity that we do remember you have organized a Gujarat Science Congress in the year of 2016 at Bhuj.
Yes, sir.
It was a wonderful, wonderful organized, sir.
Great gathering here, 800 people.
Yes, sir. Yes, sir. A friend is a fellow of Geological Society of India, fellow of Indian Planetary Society and Indian Society of Remote Sensing, and he's an active fellow of Gujarat Science Academy. He is a founder of a Kachch Tourism and Handicraft Development Federation. Dear friend, that is a long list of his academic and administrative service. It is difficult to cover at this moment. With this brief introduction, I would like to invite our speaker, Professor M. G Thakkar, for his presentation. I take the opportunities to thank him for accepting our invitation and being with us. Sir, thank you very much, and over to you, sir.
Thank you, sir. It is my pleasure. Thank you, sir. But I don't need this long introduction, sir.
Sir, you deserve it. Sir, you deserve it.
I am lover to the science and lover to the science lovers. So that is the only qualification and introduction.
I saw there is a long list of your administrative and academic service, sir. Salute to you, sir. Salute.
Thank you, sir. Thank you. So thank you very much for giving me this opportunity to speak with all dignitaries as well as to the science lovers of Gujarat or maybe outside Gujarat. And I pray for everybody, those who are actually suffered or suffering from COVID-19. And most of the positive people, those who are on the line, and they are really, I hope they are enjoying their time, lockdown time. Basically, the positive people, they are enjoying the lockdown time. And COVID-19 is there, and that shows us the dynamism of the earth. I tell you, ki, dynamic part, I start the earth as a dynamic planet. The COVID-19 has made everybody dynamic, right? From the earth to our life. Everything is now dynamic. But I don't cover this topic. The microorganisms, they have covered the world today, and they have ruled, they are ruling the world. There's a virus and bacteria. But of course, I would tell you that our body is full of microbes, and we are governed by the microbes. Each and every cell of our body, maybe 1 trillion of cells, they are all governed by the microbes. So we cannot deny the microorganisms' role. Let us, Jai Hind to everybody, all participants. I will start my lecture with the, everybody can see the slides, okay? Because there are so many photographs. And
yes, we can see, sir.
So many photographs and slides, it should be shared. Otherwise, the dynamism of the planet is very difficult to show to the audience. So my talk as a dynamism of the planet or dynamic planet, that is organized in 4 different ways. The 4th point is not going to be covered, that I think recently I have just mentioned. But the first 3 topics, that is the dynamic Earth with respect to the astronomical positions, the Earth's astronomical position and its motions. So in first few minutes, I will talk about the motions and that dynamic positions, astronomical positions. The second part will be covered, which is the dynamic Earth with respect to its inherent energy. Earth has its inherent energy. So I'll talk about the most of the evidences that we can see and feel with respect to that inherent energy system. So it is a vast system. And the third is the Earth, which is dynamic with respect to the energy. It receives the energy from the outside world. So what is outside world? Our great father is the sun. So we are receiving the energy from the sun, and with respect to that energy, we are also dynamic. And as you know, it creates the climate. So climate is a major dynamic factor which we feel generally. The inherent energy which actually been portrayed by earthquakes and volcano, and of course the tsunami, and there are several other calamities or the hazards which we can say they are all mixed, not only one factor which is responsible for the those calamities, which I can give you one example as landslides or the avalanches. These are all mixed kind of calamities. The fourth one is not going to be discussed right now, because that is with respect to the all combination of all these three dynamic elements. But ultimately, we are living with respect to this fourth element. We have been evolved from the unicellular animal to the cream, like the human, the supreme of the nature. Okay, supreme of the nature, not nature, but supreme of the all organisms which we see only on the earth. So let us now look at the dynamism of the earth with respect to that astronomical positions. If you can see the left side of the screen, the earth is part of the big system which we call the our own solar systems. The sun is the father of our all planets. There are 8 planets moving around the sun. And how the solar system formed. So this is a small picture which gives you the idea that how the earth is formed. So first thing is how the earth is formed, but earth is a part of several other things. So that I want to share with you, that when earth formed through the solar system formations, that is a big that is a big hypothesis, and then ultimately several small planetesimals, they accreted and they made several planets. Out of them, we have terrestrial planets and the Jovian planets. So we are the part of the terrestrial planet. So now you in other right side of the presentation, you can see the sun and their respective positions of the earth. Sun is the diameter of the sun is around 1.39 million kilometers, and our diameter, the earth's diameter, is 6,371 kilometers. And in the second picture of the sun, where you can see the big flares or corona which is coming out from the solar surface, where a small point is given, that is the earth. So it is so infinitesimal in terms of the entire sun. So now it is just to show you the positions of the sun and the size of the sun and the earth. Now in the other part, left side, where my cursor is there, you can see solar systems, the smallest part, which is the terrestrial planet part. Now look at this picture in the middle, where the solar system is surrounded by the Oort clouds. And this is actually the magnetosphere, which is sheathing the earth and the entire solar systems. So this is very important. I just want to show you that the total diameter of this sphere, okay, that is more than 200 astronomical unit. Now moving to the other slides. These slides will give you the picture of the Milky Way Galaxy, where we are, the sun, our sun is the part of that galaxy. This is the position in the yellow colored arrow. If you can see, this is the position of our sun. Our sun is the member of this entire galaxy of more than 100 billion stars. So you just think about our sun is a tiniest object in the entire galaxy. I just want to show you the size of the universe, size and with respect to the size of the earth with respect to the universe. let us see the distance of the galaxy. It is more than 160,000 light years is the diameter of the galaxy, and almost 1,000 light years is the thickness of the galaxy, in which we have almost 100 billion stars in our Milky Way. I am not going into detail of all astronomical units and everything, because I presume that this is all basic things all science students must know. Now, what I want to share is our sun is also moving around the galactic center. You can see the galactic center is glowing with the some millions of stars. How much time it takes to rotate the sun, our sun, around the galactic center? That actually takes 250 million years, one rotations. So that is huge time. 250 million years ago on the earth, we didn't have even dinosaurs. They started 240 million years. So dinosaurs came, and now the perfect human developed or evolved on the earth. So this entire period, only one rotation is over of our sun. So now, looking beyond this galaxy, there are several other galaxies. I can share you in the middle part of the picture. The Milky Way is a small galaxy. It is surrounded by some other constellations, and the neighboring galaxy is Andromeda. If you can see the Andromeda, there are three neighboring galaxies of our galaxy. And this entire unit is also behaving of one unit. And they are the part of the small local fluff or local bubble. And this local bubble, you can see here, the galaxy is a part of this small local bubble and local fluff. And they have, I can't share you the vastness of these local bubbles, because a small galaxy has 1,600 light years of the diameter. You can see several other galaxies, they are making a cluster. And this, all clusters, they ultimately have, there are several billions of these clusters, and they make the entire universe. So in this picture, you can see the Earth makes, where is the Earth? In the solar system. Where is the solar system? In the universe, in the Milky Way galaxy. And where is the Milky Way galaxy? In the local group. And where is the local group? In the local supercluster. And where is the local supercluster? In the entire universe. The background web, you can see, is kind of filaments. And this filament, each filament, not, but each glowing point is galaxy or supercluster. So this is the vastness of the universe. We cannot even think about the vastness, because in the next few slides, I will give you our motions, how dynamic our Earth is. Because now we switch over directly to the Earth. This is the relative size of the Earth. The small arrow, red colored arrow, you can see is a small Earth with respect to the entire sun and the other planets. So there are around 1 million Earth can fit inside the Earth. So that is very important to understand how infinitesimal the Earth is and how big we are. So we have so much of ego, but now with this, after 1 hour, everybody, those who are listeners, they should come down to the Earth. And Earth and the universe is the master of everybody. And instead of bowing to the idol of any god, you should bow to the nature. Anyway, look at this picture where the Earth with respect to all the planets. Okay, now I want to say something about some mind-boggling facts. What is that mind-boggling fact? That the spinning of the Earth, which you can see in the left side of the presentations, we are in the motion. The Earth is in the motion by 1,666 kilometers per hour. The spin of the Earth is so fast. When you are driving a car with 100 kilometers per hour speed, you can understand 1,666 kilometers per hour we are moving. The earth is spinning. Look at the other part where orbital rotation of the earth. See the figure, we are in a spaceship, it is called the earth, and it is moving around the sun with the speed of 1,07,460 kilometers per hour. It is mind-boggling speed. Can you imagine with the spaceship you are moving with 1 lakh kilometers per hour? It is really, really wonderful, amazing. Now, more mind-boggling facts you can see. We are also, our sun is also moving with 7 lakh kilometers per hour around the galactic center, because it takes 250 million years to make an entire rotation, and that rotation is around 59 parsec. The distance is parsec. We are not going into the details of the parsec, but the total, the calculated value is around 7.07 lakh kilometers per hour. This speed, sun is moving into the space with respect to the sun. Now coming to the earth, with knowing simple positions and the movement or the dynamism in the astronomy or in the space, now we come to the very small, very tiniest kind of small virus the earth is, but that is very important. Earth has the structures which everybody knows since 8th or 9th standard. Most of the students, they are aware about the earth is divided into 3 major divisions: the core, mantle, and the crust. Crust is just 40 kilometers, or sometimes it is more than that. Okay. Mantle is around 2,900 kilometers thick, and core, liquid iron core, is surrounded by the mantle, and the inner core is a very solid, and it is made up of the nickel and iron, and that is very important. The earth is having these distributions. I want to say that this distribution of the core, mantle, and crust, that is the boon of the life. That is the only thing which separates or differentiates the earth with the other planets and the live planet, other planets which is made. Of course, the other planets do, they do have the core, mantle, and crust kind of internal structures. But the earth is different. Why? See, this is very important, that the core is having some certain kind of the gravitational, specific gravity. And that is more than 13 gram per cubic centimeter. And that has given, because it is made up of the iron and nickel, it has given us the magnetic property. This magnetic property, as well as the gravitational property of the earth, which is the boon of this universe. I tell you, still till date, we have, or the scientists have not found a single planet where such a powerful evolutionary system, biochemical, biogeochemical systems exist. Anyway, why I am just pausing here and giving you more stress upon the core, mantle, and crust, because this is the driving force of the dynamism of the earth. You must understand the solid iron and nickel core, and surrounded by the liquid core, which is having nickel and iron sulfides, and they are all very highly radioactive. So now we move to the their properties. But before we got this divisions or differentiations of the elements, that the heaviest part in the middle, center, and the lightest part, they made the crust as well as the atmosphere. But atmospheric gases, they have been bound or they have been captured by the earth through gravitation. So we need a gravitation first to capture all the gases which cannot escape and makes the earth as a closed planet, and that they did, or the earth did during the early days. What early days? We call that early period is hidden era. Hidden era or Hadean era. That is 400 million years of the beginning. That means the beginning of the earth is around 4.5 billion years. So early 400 million years, that means 0.4 billion years, that has actually given the distributions of the earth's crust, that has given the magnetic field, that has developed the gravitational. So what during this period or during the other Precambrian period or Archean period, what happened? Atmosphere throughout the Hadean, we will discuss about it. Oceans formed, but not water. But water came later. Water came around 4 billion years from today. Crust and continent formed. Plate tectonics starts around 4 billion years. And magnetic, at the time of the earth formation, magnetic field started. And that is actually very much needed. How the picture was of the earth was. You can see one big picture having a liquid ball, huge liquid ball. Did not have the atmosphere, did not have proper gravitations. That is why what happened, several comets, several asteroids, they accreted on the Earth's surface, and it actually gave the energy. So Earth heated up slowly and slowly with respect to these three major processes. One is an accretion process, that means impact of the craters, and that gave the energy to the Earth's surface. The other is differentiation. The lighter elements came up and heavier elements sunk down and made the core, and the radioactive decay of the elements, that is still going on. Radioactive decay and the heat convections, that is still going on. That actually made the entire planet alive. So in this particular slide, you can see heat escapes every day. Every day Earth is dying. Of course, just like our life system, the Earth has a life system, Sun has a life system, and it is dying. How it is dying? Through the heat. It is escaped through three different processes: radiation, conductions, and convections. So all these three processes that dissipates the heat. How we experience those heat transfer, heat dissipations through earthquakes and through volcanoes. So in the coming few minutes, a few slides, we will be talking about the dynamic crust or dynamic mantle and dynamic lithosphere of the Earth through dissipation of the heat. So heat is one of the major issue or major element which we should know today. How the present Earth, which we see, we live on it, is formed. Earlier there was no water, but even there was no continent because it was a liquid sphere. But slowly and slowly heat dissipated and it made a solid crust, lithospheric plates. How the lithospheric plates made? There are two different lithospheric plates. One is a continental plate and the oceanic plates. So the first one is formed is the oceanic plates. You can see the cometite, kind of the high density FeMg silicate minerals made up of the FeMg silicate minerals, that cometite and other heavy mineral crust formed, and that is called the basaltic crust or cometitic crust. So early crust formed in different ways. The lighter element when came out from the mantle, they made a crust, and that is the low lithophile silicates. Now look at this picture where early atmosphere formed. We have early atmosphere during the origin of the Earth to the around 4.3 billion years. So that is called the primary atmosphere formed during this almost 300 to 400 million years. Secondary atmosphere formed due to the outgassing of the volcano, because the volcano they effused the low density material, and it is actually the distribution of the elements into the earth. So there were several volcanoes during those time. That time the crust was not that thick and not that solid. So that time, almost around 2.8 to 2.9 billion years, this activity was in practice. But the most important, where we are living, where oxygen, when oxygen came into the picture, it was around 2.9 to 2.8 billion years. How oxygen actually, in the free oxygen, came into the ocean and came onto the earth. That is very important. We are not going into much detail of all processes occurred on the earth's surface, but I would like to mention and show to everybody that these all processes which already occurred, we are now at in the present day. We can't see the processes, but the earth, the rocks on the earth's surface, below the earth's surface, they can give you many things. Even the physics, I just want to give you one good you are the physics background, all students are mostly of physics background. Without physics, the geologist could not have made this progress to understand the earth's surface, to understand the earth's interior, to understand the billions and billions of kilometers or millions of light years away, what objects are doing or how it is moving. Through the physics only, we could do this. In our science, in geological science, physics has played a major role in last 20 years. Without physics, several instruments, we are now crippled. With the help of the dating methods, with the help of the OSL dating, several dating methods and isotope studies, it is totally zero. I tell you very frankly, the basic geology is already been done by several people since last 200 years. But today's understanding of the geological science, that has made physics has made the science known to everybody with all intricacies. Now we are moving to the, once we formed the continents, small continents, and plate tectonics started around 4 billion years from now. This plate tectonics is the major phenomena. It is not one phenomena or not one plate tectonics. Where we are living is the latest plate tectonics. Everybody knows that there was a big Pangea and it was divided into Laurasia and Gondwana land. After that, the plate is separated into Africa, South America, Antarctica, India, Australia, and they are drifted. And ultimately, we have the present day geographical positions of the plates. But it is just 230 million years old plate tectonics out of the entire 4.5 billion years of the age of the Earth. And I told you just now that 4 billion years is the point of is the time where the plate tectonics started. So there were several other plate tectonics which are already identified by the geologist. How we identify the plate tectonics, that is a big issue. But you must understand that there are 5 plate tectonics identified by geologists. Out of the the latest one is known to everybody, to all school students and the common science students. Look at the 1.5 billion years old plate tectonics. We call them Columbia plate tectonics. The other started in 1 billion years from now. It is called Rhodania big continent, and that actually is collaged and separated. So making a big collage and separations, drifting and drifting, and making somewhere a big collage or joining the plates together. This is a continuous process now you should come to know. And the latest 1.5 billion years, that means 500 million years, is Gondwana, I mean our latest plate tectonics. But the drifting of those Gondwana started 240 million years from now. And now these slides will give you that pictures, that how the big Gondwana land or Pangaea divided into two, Gondwana and Laurasia. This is very simple, and since 8th or 9th standard, most of the science students, they know, so I'm not giving much time to particular the slides, but one thing you should know, that this is not a science fiction. It is with the facts. It has been proved that all continents, they were together once upon a time, maybe 230-40 million years from today. So these pictures are the evidences. We have the evidences of the similar fauna and flora. We have evidences of the similar mountain chains or the rock bodies in presently far away continents. We have continental shorelines, which is matching. You can see South America and Africa. The continental shoreline is exactly matching. If you cut the world map and put together, it is a kind of jigsaw puzzle. Very simple thing. But my the point which I want to focus on, that once we got the magnetic field, everybody from the physics students, they know that Earth is a giant magnet, big magnet. Everybody knows that if I put the compass or magnetic needle, like a Brunton compass, it will be oriented north-south because of the Earth's magnetic field, which you cannot see, but you can feel with the help of the needle. Does this activity or does this process existed some few billion years, million years? Yes. And do you really understand what kind of magnetism was there? Once we scanned the Earth or the ocean of the Earth, 1960 around, there was a big project by USA and Russia together. They scanned the entire ocean platform or ocean bottom. They come to know that there are rocks which is having strongly magnetic, which is having the normal magnetism, that means north and south. But some rocks from the main axis of the mid-oceanic ridges, some rocks which is having not a normal, we call them reverse magnetisms. So you can, the magnetic property of the Earth can be stored in the rocks. It may be a igneous rocks, it may be a sedimentary rocks, or it may be a metamorphic rocks. But mostly it can store into the strongly magnetic minerals, those rocks made up of the strongly magnetic minerals. Okay, so the oceanic floor basalts, they are made up of the magnetic minerals, and they examined thousands of rocks on the Atlantic oceans, and they come to know that Earth's magnetism, once upon a time it was normal and then reverse. So several times it got normal and reverse. So we get the paleomagnetic property of the Earth, and then we come to know about the magnetic reversal and normal. Look at this picture, that magma coming from the mantle, and it effuse the magma, lava on the surface, and make the new oceanic floor, which is called the basaltic floor. And slowly and slowly, this plate is moved to right and left. So it is away from the axis The magma, when it comes and pile the sediments or magmatic material, both the plates are pushed away, and they are the youngest basaltic rocks. That I want to focus upon this particular fact, that the youngest rocks are in the middle part of the axis from where the lava is coming up, and the oldest one the farthest. Based on this, if you scan the Atlantic oceans, the mid-oceanic ridge, in the middle we have got youngest rocks and oldest rocks to the close to the continents. So they argon and other uranium thorium dating method, with the help of those dating method, they come to know that they are not older than 180 million years. So any of the oceanic crust on the Earth's surface is not older than 180 million years. So that's why you can have the evidences that once upon a time, 180 million years ago, they were all together. With a small example, we have given us last 4 million years of magnetic reversed and normal activities. That is called the Gilbert-Goss, Matuyama, and Brunez rivers. Okay, we are not going into much detail, but this we have found on the ice sheets of the Earth's surface. Okay, and now look at the pictures, how the plate tectonics, the process occurs. From the mantle, deep beneath the mantle, convection through the convection currents. The convection is basically transmitting the heats from the core to the mantle, and it comes on the just below the lithospheric plate, which is moving. That heat energy, which is converted here, exactly at the boundary of the asthenosphere and the lithosphere, it is converted into the mechanical energy, and it moves the plate through the mechanical energy. And that mechanical energy is responsible for the earthquakes and the volcanoes. It goes down and digests in the mantle again, this cool plate, and it affuses the low density elements on the surface, and we have got the silicic or kind of volcanic eruptions. Look at this. Based on all this realm of the plate tectonics, we come to know that Earth is a collage of 7 major plates and 8 minor plates, total 15 to 16 plates. Out of them, the Pacific plate is the largest one. And that is the only, not largest one, sorry, but it is the only oceanic plates. While Eurasian plates, Indo-Indian plate or Indo-Australian plates, then there is a South American, North American, African plates. All these make us collage, but they are moving with respect to each other. That is the fact. And when they are moving with respect to each other, their boundaries are very vulnerable. And these boundaries are important to show that Earth is dynamic. These boundaries are responsible for the earthquakes and volcanic eruptions. And the geologists have divided these boundaries into 3. One is a divergent boundary where the lava comes up and makes a new lithosphere. The other is convergent boundary where the old plate goes down, subducts down, and digest themselves and make the new crust. While the transform fault boundary where 2 plates are moving side by sides. These boundaries are shown into the details over here. The divergent boundary, which is the center of the magmatic eruptions, but very low earthquakes and very low volcanic activities. Quiet volcanic activities are responsible here. This boundary is responsible for quiet volcanic activity. While violent volcanic activity, violent earthquakes or devastating earthquakes, they are concentrated at the convergent boundaries. So with the plate tectonic knowledge, we come to know many things, which is related to the human, which is related to the other activities on the surface, landscape surface, which is very important for this particular talk. the third phase of my talk. In the lower right side of the picture, you can see the Indian plate moved to the north, and in between there was a big ocean that made the Himalaya. So it is collision of the Indian plate with the Eurasia that created a big Himalayan or youngest Himalayan mountain chain on the earth. So that is very important. You just keep this in the mind, because we are going to talk about this in the later part of the lectures. Let us look at some other way of the dissipating the energy from the interior of the earth. One, we have seen the fissure kind of eruptions, and that made the move the different plates away from each other. But some central kind of eruptions, there are some centers on the earth's surface which is called the hotspots. So from the one point the lava comes up, and they are all stationary points because they are connected with the mantle plume. Okay, that is a big heat source. So there is a big this picture you can see the hotspots, very famous hotspots of the earth is Hawaii hotspots, and the Hawaii island chain that actually shows you the movement of the plates. Okay, because the hotspot is stationary and plate is moving. Okay, so how and which direction the plate is moved through, you can say about the movement of the plates. One of the major hotspots which actually created western part of India is called reunion hotspots. We'll talk about it later. But let us summarize the plate tectonics. How after all this knowledge, you might have one question in your mind, that how these plates are moved and how what is the driving force, mechanical energy force behind all this. The researchers agree that the convective flow in the rocky 2,900 kilometer thick mantle is the basic driving force of the plates that I already mentioned. And I also mentioned about the slab pull and ridge push. From the ridge, it is a pushing, and from the end of the other end, where there is a subduction zone boundary, where the ridge is pushed. So this is one of the debate amongst these geologists. And what is the importance of the plate tectonics, that I also mentioned, that we can know much about the earthquakes, volcano, and mountain buildings. Last 70, 60 years, when it is since the advent of the plate tectonic science, the geology, which is the old science, I mean systematically old, 200 years back, geology was in the books, very good, classified, different rocks and everything was there. But their old fundamentals, they are changed after the advent of the plate tectonic science. Our igneous petrology, metamorphic petrology, the fundamentals are changed. Many things are changed because we didn't know many things about the below the earth's surface. And now we know through physics, through geophysical methods, through earthquake geophysics, we come to know about the interior of the earth and their properties. Of course, plate tectonics gives you how the distribution of the plants and animals on the earth's surface. So that is a big issue by itself. Japan, I'm just skipping these slides, but we come directly to the earthquakes, which is the basic building blocks of the major movement, tectonic movements. And this is the only process by which you can feel that Earth is still live. Earth is a dynamic. So through several earthquakes, we have the topographical changes occurred through earthquakes and through climate. So we are talking about that processes. But this process of the earthquake, which is the result of the large tectonic plates, movements of the tectonic plates, this gives you a small this idea about the epicenter and focus. Focus is where there is a rupture below the Earth's surface. It could be 10 kilometers, or it could be 100 kilometers. But it is the point, or it is the place below the Earth's surface where rupture starts. What is the rupture? When you have a mechanical energy that moves the plate, and how the plate moves, and it actually produce the earthquake. Very simple fact I can share with you, that you have a iron rod, and you move iron rod from both the sides, and you hold the ends, and you just apply your force, you release the force. After few little force you apply and release, it will come again to the original position, because you are not crossed the elastic limit, but you apply more and more force. After one point of time, the bent rod will remain bent, because you have crossed the elastic limit. But even if after that you apply more and more force, what happens at one moment, the rod will break, and that is called the earthquake. So that happens in a large lithospheric plates. The mechanical energy is stored, and at one moment of time, it crosses the rheology, or the strength of that material of which the plate is made up of. The rupture will start, and that is called the earthquake. So the energy will be dissipated through the earthquake waves. So you can see the earthquake is known as the elastic rebound theory, very famous rebound theory, and the one which I explained through the rod, it is shown here by the plates, that it's an original position and deformed positions, then again it is a quiet position, that it gains the new positions. So it is called the elastic rebound position. What happens when the energy release, and all four sides, all sides from the focus, there are three waves produced from that center. One is a P wave, that is called body wave. Another is S wave, it is also a body wave. P wave is a primary wave, which is the strongest, and the velocity of that P wave is highest. It is around 7 to 8 kilometers per second, and it mimics the sound wave, and it can pass through the solid as well as liquid. While S wave, which is called secondary wave, which cannot pass through the liquid, and it is behaving as the electromagnetic wave. That means the line of propagation is the line of the particle vibrations, or the direction of the particle vibration is perpendicular to the movement directions. While here, both are same, parallel. This is also called the shear waves. This is called the push wave. Okay. Now, the most devastating is the surface wave, which actually travels on the surface as just below the surface. And they have two different types, relay wave and love wave. The cartoon will give you how they are moving. Basically, the relay wave is kind of wave, and the love wave is like the serpent which moves on the ground. So that is actually responsible for the large-scale devastation on the Earth's surface. Where are those earthquakes? They are frequent. 80% of the earthquakes and volcanic activities, they are surrounding the circum-Pacific belt, which is called the Pacific plate. Surrounding the Pacific plate is called circum-Pacific belt. More than 80% of the earthquakes. Rest 15% is concentrated along the Himalayan Alps, that is called the Mediterranean Asiatic belt. And rest others, only 5%, they are within the plates. So within the plate earthquakes are not very harmful, but the Kutch earthquake, which is within the plate earthquake, that is a devastating earthquake. And that is why the importance of the Kutch earthquake was very great amongst all geologists. Put aside all activities, because this is very long processes and very elaborate processes of the volcanic activities. Volcanism is also one of the evidences of how the earth is actually breathing. So I have given you a small example of the Deccan volcanic activities. Around 65 million years from today, there was a big activity, not one day activity, but it lasted for almost 6 to 7 million years. That activity, volcanic activity, has given rise a long Deccan plateau. When you move from Mumbai to Pune or Amarkantak, you can see the Ghats, and these Ghats are having parallel layers, which are all basalt and other volcanic rocks. This entire plateau is made up of the volcanic rocks. So there was a huge eruptions that is called the reunion hotspot eruptions. Now we move to the other phase of the lecture, where we are now on the Earth's surface. How lithosphere developed, how hydrosphere developed, we talk much about it. How atmosphere developed, we talk little about it. But how anthroposphere developed, we have not talked about. How biosphere developed, these are all big events, and which itself is kind of a big course. So I just mentioned that entire Earth is made up of several spheres, and they are all moving, they are all dynamic. By itself, they have interactions with each other. Hydrosphere has interactions with the lithosphere. Pedosphere has interaction with the biosphere and hydrosphere. Every sphere has interactive properties, and that is very important to know. Now, as we talked about the endogenic processes, which is earthquakes and volcano, and many other small events, there is another process which we are now focused upon, is exogenic process. That means the energy which we are receiving from the others. That means not other. Sun is not other. That is our father. Do you know that endogenic processes by which we are live in the sense the plates are moving, that also is inherited energy. It is inherited from the sun. So we are using, the earthquakes are basically the inherited or remnant heat, residual heat since 4.5 billion years, and it is dissipating today. It is we are losing it today through the earthquakes. Every earthquake, every volcano, that will, it is dying our earth. Now, see, the other phase of the lecture is exogenic processes. Exogenic processes also gives you the sun gives us the energy, and it makes the climate. So the role of climate in the shaping the landscape is very important, and that in that sense, Earth is also dynamic. So look at how big events through which big events the Earth changes the landscape. The major one is a flood, cyclone, and tsunami, and many other slow erosion processes, which we are going to discuss today in the second phase of lecture. Look at this vast young mountain chain, which is known as the Himalayan mountain chain, and below it is a flat Ganga plain, and below the Ganga plain, or Indus and Ganga plain, we have old mountains. Out of them, you can see a one line, which is Aravalis, around 2.5 to 2.9 billion years old Aravali mountain chain. This is the oldest in India. There is another mountain chain, which is Nilgiri, Eastern Ghat, and the Dharwars. So these are all old tectonics, which are I'll discuss not much about this tectonics, but the major issue which is that this is young mountains and that has influence on our life on the plane, making the plane and all life which breathe during the human era, that means last 5 lakh years, to the civilizations. That means Indus Valley civilizations to the Vedic civilization in the Ganga plain, all are affected, and they are influenced by the latest erosional or climatic and tectonic processes. See, my point of focus over here, that this tectonics are uplifting the mountains everywhere, and the climate which degrades the mountain. So this is the idea of all rest of the maybe 10-15 minutes. Look at this picture where we have old rocks, 1.9 to 2.9 billion years old Archeans to early Proterozoic rocks. They have sediments, they are sedimentaries and metamorphics. Here you have 2.3 billion years old banded iron formations. Just remember this banded iron formation, because I am going to talk to you about something important of this, because I just want to show you that this banded iron formations is the later period. But 2.3 billion years old stromatolite or the cyanobacteria, that has gave the oxygen to on the earth. When oxygen came in the atmosphere of the Earth's atmosphere and the oceans, then everything starts, because cyanobacteria is responsible for the oxygen sphere on the Earth. But who used the all oxygen, initial oxygen on the Earth's surface? This banded iron formations is the evidences of how the rocks or the earth processes, they used the oxygen. The oxidation process, iron oxidation processes, that actually started something around 2.3 billion years from today. And after that, oxygen was used. Again, how bacteria gave the oxygen. So these are all biological and biogeological and geobiochemical processes. It is a big domain by itself. In 1 hour, I may not include all these talks. Look at some other pictures, younger pictures. 350 million years old Paleozoic limestone rocks. This view photo I have taken in South Africa, near Cape of Good Hope. 170 million years old Kachchh, Jurassics of Kachchh. Why I am mentioning that, you will come to know that the dynamism of the earth, this will give you the dynamism of the earth. So after the advent of the oxygen, after the advent of the cyanobacterial life, one cellular life to the multicellular life, then there is an evolutions, and slowly and slowly, but for several millions of years, several billions of years, from 2.3 to 590 million, 2.3 billion to 590 million years, there was no hard skeletal life. So we could not have any skeletal remains, and we know not much about the early life than 590 million years. But you can see these pictures where several organisms, I have shown several organisms from the early 590 million years trilobite life to the Jurassic life, ammonites, how ammonites were moving in the Jurassic oceans, and same time how dinosaurs were moving on the continent. And here a big skeleton of the Ichthyosaurus marine reptile is discovered. How? Okay, so look at this Archean life to the Paleozoic life to the Cambrian, Ordovician, Silurian to the Mesozoic life. So this is the chain. I am not going to discuss much upon the life form and their evolutions, but human came last in the Quaternary period. As sir introduced me that I am the man of quaternary science. So we are working just last 2.6 million years to 0. That means from present. We are not working from 4,500 million years to 2.6. This is not of my domain. But when man came, before the man came, so this is very important period. We are not here to give you the clear all evolutionary pictures, but I want to show that biologically, the earth since the beginning or since the advent of the life till today, it was so dynamic, and it is still dynamic. I give you one small example. If you see, this is today's picture, present day sand ripples on the Kachch coast. And here, this is 170 million years old Jurassic ripples on the sandstone. So present is the key to the past, or past is the key to the present. We call in geology, it is called the Uniformitarianism Principle. But Uniformitarianism Principle gives you the slow erosion, slow depositions, and all slow processes. Whatever we are now move to the how Himalaya formed. As I told you in the earlier picture, that how Himalaya formed and how they have changed the entire human dome, entire civilization, entire new domains. Now we come to know about the tectonics. If you can see the mountain chain, here there is a clear-cut demarcation of the boundary where there is a mountain ants and the plain region starts. This is very common in all Himalayan roads. When it enters into the Himalaya, these are very common features. The idea behind this picture is this part is tectonically uplifting, and tectonic forces are uplifting this mountain, and climatic forces, they all the time degrade these mountains, and they make the sediments downstreams. In this picture, I want to show you about the young glaciers. If you can see the youthful glaciers and glacial topography after the Himalayan adventment. This picture is taken by me while I was flying from Delhi to Leh. So it is around Leh or a little bit away from the Leh. You can see very good glaciers. These glaciers, they are basically source of the water as well as source of the erosion, and this erosion will give you the all Ganga plain and everything. So this is a major driving force of the civilizations. The climate, so with this you can understand the climate has major role in carving the landscape. Some more picture of the glaciers. You see some glaciers, 1, 2, 3, 4 glaciers, they come together and make a large glacier. Okay. So this is a famous glacier, widest, longest glacier of India. This valley, these glaciers move slowly and slowly, almost few feet a year, and they erode the valley. And what actually they put behind is a zigzag topography. Look at this zigzag topography. And look at the last 20,000 years old glacial maxima to the interglacial period. So in the glacial period, which was 20,000 years to 18,000 years, it was glacial period on the Earth's surface. Entire Earth was temperature was very low, and these glaciers you can see at very rear corner. They were all these valley were all valleys were studded with the glaciers, and these glaciers are receded slowly and slowly. This gives you a picture, a very good downstream plains and life to all people on the Earth's surface. This picture will give you how glaciers are. The snout is dynamic. This is the snout. This is the only glacier in India which you can touch the snout just parking your car somewhere, and just by walking half a kilometer and you can touch the snout of the glacier. That is Kachchh Glacier. This was the picture of one of our field programs, DST sponsored field program. Now, the glacier when recedes or advance, they put behind a large valley, and this is called the U-shaped valley of the glaciers. The glacier, and this topography is called the zigzag topography. So this is why I am showing it to you, just to show the glacial erosion, and this is very important for the downstream all dynamic topography, because here the vegetation is sparse. There is not much vegetation entire year, but there is only erosion. So these people over here, they are withstanding the erosion processes, withstanding the life without water, but giving the life to the downstream people. So this is it's a kind of conflicts in Himalayan regions. Mostly in the higher Himalaya to the lower Himalaya, it is a conflict. I will skip those slides because this will give, this is the same picture how in the Leh, this is Indus Valley. And you can see the latest fan development. So these are all quaternary deposits, but these are all Paleozoic deposits around 500 million years. And how the landscape is degrading through tectonic uplifting and incisions. So this is also the same Indus Valley. So my simple idea to transpire to you is the tectonics is uplifting the mountains or the landscape, but the climate is degrading. This is the core idea of this particular sections. Now, we are moving slowly and slowly from Leh to the downstream side. Here in the Leh, you don't see any vegetations, while here you can see lush green jungles and valley full of the vegetations. Because it gets the water. There is no ice, but water that makes the pedosphere, that makes the soil development, and that gives you the life. Greener, slowly and slowly when you go to the south, and when you leave the Himalayan mountain, you have the endogangetic plains, vast endogangetic plain, and that is the huge. Why I have given the plus, because the sediments are increment. Okay, in the Himalaya, plus means the glaciers, this plus in Himalaya, higher mountains, it is upliftment. That means the energy is given by the internal heat and it uplifts the mountain. Here plus is due to the sediments it receives. And there are some other pictures of the Meghalaya plateau, which is also very young, few million years old Meghalaya plateau that is fastly uplifting mountain. Now, coming, Professor Hitesh, is it okay? Should I move further? Our last phase?
Yes, you can continue some more for some more time.
Okay. Okay. So now, yes. coming down to the young features of the Kachchh. Why I'm Kachchh? Because it is maybe because most of my research is concentrated in the Kachchh, and I have explored much the Kachchh landscape, and landscape is my passion. You see, the Kachchh landscape has very sharp boundaries. These sharp boundaries are basically depicted by the fault systems, and they are all active faults. These faults are active faults through which the landscape is uplifting. And this vast desert, or it is called the Run of Kachchh, it is active basins. It is not active seismically, but active basins where the sediments from all the sides are depositing, and we call them the factory of the rocks. So that is more than 500 meters of the sediments there inside the Run Grabens. My point of to mention over here is how tectonics in this particular landscape has made changes on the landscape. This line, my cursor, you can see the cursor line of the small uplifted terrain is Allahabad. So one earthquake just 200 years from today, that is called 1819 earthquake, has made a long ridge in the vast saline flats or the saline lands of the Great Run of Kachch. It has uplifted by 6 meters of the land, and that has changed the total topography and demography of the area. So that is what my focus of today, that how dynamic the earth is. You can see the 200 years old earthquake which has changed the topography. 2001 earthquake, I have some photographs of 2001, just 20 years old earthquake. It has also changed the topography, it has also changed the demography, it has changed the many things, but we are not much concerned today about the human psychology. But let us look at the 1819 earthquake, the effects of the 1819 earthquake. Once upon a time, this river, Nara River, was a flourishing river, and big ships were moving through this river. Now it is desolate part of the run, uplifted part of the run. And surrounding part, you can see small gullies and valleys. They are all young, 200 years old rivers. So these are new streams are developed. This is very important for those who are working on the young geomorphology. This is young geomorphology, just 200 years old geomorphology. Before that, it was just flat terrain. And this is that particular river which is now desolated. This is the way to Pakistan. So you go to the north, there is some of the ports in the Pakistan were there, and ships were moving during the princely state in Kachch. Some of the pictures I am sharing with you about the Allahabad terrain. Now look at the 2001. 2001 earthquake has also made the small scarps. Of course, it is very small compared to the other earthquakes. If I talk about the Chi-Chi earthquake in Taiwan, it has actually uplifted the surface by more than 8 meters. And but I don't share those pictures over here, because then let us look at some of the major features developed during the earthquake, 2001 earthquake. These are my students who worked under me, and this valley today and this March 2003, if you can compare this valley and this valley. So the earthquake is how an earthquake changes the landscape. So small stream which you see today may be the consequences of the large earthquakes. So you can see 100 years of tectonic changes. You can say 100 years, you can say 1,000 years, and you can say like this 1,000 years, because this particular sediments we have dated is 5,500 years old, and just near Dholavira town. And when Dholavira people were here, or Indus Valley civilization people were here, this particular sediments was not here. So how the climate also, because this is fluvial deposits, so climate also changes the landscape and how they make the planet so dynamic. And this is some remains or some remnants of our old civilizations, which is considered as the very wisest civilization, Indus Valley civilization. Some groundwater, how to store the groundwater, the drainage systems, the reservoir systems. They had fantastic systems in this Dholavira town. Okay, why I'm mentioning here that the man is also one of the element in the dynamic planet. Okay, look at some pictures where dynamism is very much seen. This crack is not very old, very in geological sense, maybe 50,000 years. So we are dating these particular locations through many different methods in physics. And this is lava. All kits, dynamic kits are jumping on the dynamic planet. Thank you very much for your kind attention. Thank you, sir.
Yes, sir. Thank you so much. Now, sir, we can take the question and answer session.
Yes, yeah.
Yeah, so those who have questions, just raise your hands and we will allow you.
Is there anybody who
Yes, there are many, sir.
need interested to ask the questions?
Yes, there are many, sir. One person named Limbani Ajay.
Hello, sir.
Yes, yes.
सर आई एम अ फिजिक्स स्टूडेंट.
Okay.
सर मुझे क्वेश्चन ये है कि हमारे देश में और विश्व में बहुत सारी माइंस एक्टिविटी हो रही है.
Okay.
तो हाँ, तो माइंस एक्टिविटी में सबसे पहले माइंस क्लोज करने की प्लानिंग होती है. तो माइंस बंद तो हो जाती है, पर उसमें से जो मेटल और ये मिनरल्स निकाल लेते हैं, तो उसकी वजह से जो पृथ्वी के मैग्नेटिक फील्ड में कोई असर होता है या नहीं होता है, अगर होता है तो वो किस प्रकार से पृथ्वी को नुकसान करता है? थैंक यू सर.
मैग्नेटिक फील्ड, पृथ्वी का जो मैग्नेटिक फील्ड है उसका मेजर रीजन उनका सॉलिड कोर है, जो आयरन और निकल से बना हुआ कोर, वो उनका मेजर रीजन है. जो ऊपर जो छोटी छोटी माइंस है, द स्मॉल माइंस इन द अर्थ क्रस्ट, that are infinitesimal, that has no value in front of the major magnetosphere and our magnetic property of the earth, because the earth crust is very small in terms of the entire giant magnet which is lying below. So there is no, because it is a very local phenomena. It is not actually 1% of the entire earth mass, not 1%. Okay.
Okay.
Yes,
but sir, depth of the mining activity is 50 to 70 meters. Sometimes it's 100 meters. That means 0.1 kilometer. And average of the radius of the earth is 64 kilometers. That means 1% of the radius we are just digging it. Then
radius of the earth is 6,371 kilometer.
Oh, sorry, sir.
6,371 kilometer. The deepest mine in India is Kolar mine.
Yeah.
And that has gone up to 12,000 feet, I think. 12,000 feet. So it is also 1 or 2 kilometers.
Yeah.
But it does of no much influence on anything except the human sphere or anthroposphere. हम जो जीते हैं उनमें कुछ प्रॉब्लम आता है, कहीं सिंक हो जाएगा, हम पेट्रोलियम निकालते हैं तो कहीं बड़े बड़े सिंक भी हो जाते हैं, हम ग्राउंड वाटर निकालते हैं तो उसका इम्पैक्ट लोकल होता है. लेकिन जब आप सोचोगे पूरी पृथ्वी के बारे में, तब इनका कोई वैल्यू नहीं है.
Yes, sir. We have a next question from Gaurav Prajapati.
Yeah. Hi, Gaurav.
Hello, sir.
Hello.
Hello. So my question
Shiva,
is.
Shiva in your. Okay. Huh.
Hello.
Yeah.
Yes.
Hello, sir. Since the motion is relative concept, what is the reference point for calculation of different motions of Earth, like rotational or orbital motion?
Rotational motion of the Earth, or the which motion you are talking about? It is related to Earth. Whatever we measure. Hello, Gaurav, can you hear me? Hello, Gaurav.
Yes.
Whatever motion you measure on the Earth's surface, it is all related to the Earth. Simple.
Yes, sir. Now
if I say that Earth is moving around the Earth, Sun, so that is also relative. Okay. Whatever is that, everything is relative. You are the student of physics. You know much better than me that everything is relative. If you go and change your position to other planets, your change or measurements and everything will be changed.
Yes, sir. Now we can take the next question from Neeta Beshid.
Hello.
Yeah.
Morning, sir.
Good morning.
I would like to ask you that how much scope physics students have in the field of geology?
How the physics scope? There are ample scope. In my talk, Neetaji,
Yes, yes,
can you hear me?
yes, sir.
In the beginning, or maybe in the middle of the talk, I told you about the physics has major influence on geology today, because not a single rock is analyzed without the help of the physics. My XRF analysis, X-ray fluorescence spectroscopy, X-ray diffraction spectroscopy, then OSL, optically stimulation luminescent dating methods, EMS dating methods, many things. We are now crippled without you.
Okay.
Yeah.
Yes, sir.
So I cannot give you each and every example that physics is responsible. If I want to go for the geophysical, to find out what is below the surface, I must give your advice. Geophysical methods I have to use. There are several geophysical methods.
Yes, sir. We have a next question from Ajay Majetia.
Okay. Yes, Ajay.
Hello.
Yes, I can hear you, Ajay.
Sir, during the earthquake, hello?
Earthquake.
During the earthquake, P and S wave are produced, or hello?
Primary and secondary waves. They are produced during the earthquake, at the moment of the earthquake.
And how can we distinguish if P waves are produced or S waves? Any detector is there, or?
Yeah, if you have the seismogram with you, or if you go to the laboratory, seismic laboratory, you can find out the first wave which comes, the strong wave, P wave comes. That is the first wave. Otherwise, after that, some interval of time, few milliseconds, the second wave will come. So seismologists generally, you physics people generally can understand the characteristics of the P and S waves, but they can be distinguished with the help of the receiving points at the seismogram. Yes.
Chintan, I would like to ask one question to sir.
Yes, sir.
Chintan, can I ask one question right now?
Sir, bolo, sir.
Sir, would you please explain what is tsunami and how it is produced, and which wave is responsible for the tsunami? For the benefit of
tsunami is basically, sir, can you hear me?
Yes, I can hear you, sir.
Tsunami is basically a submarine earthquake. Yes. The earthquake when comes on the continental part, which we can feel and see, like what I explained about Chichi earthquake or Kachchh earthquake, Bhuj earthquake and Allahabad earthquake. But the earthquake which displaced the oceanic plate and produce tremendous energy and produce the P and S waves that can generate the energy, that can dissipate the energy within the ocean, and from that energy which produce the large waves, but that wave has a very low amplitude. Yes. Okay, 2004, 26 December 2004, there was a huge tsunami developed due to the Andaman Sumatra earthquake. So it has displaced around 7 to 8 meters of the Indian plate down the Burma microplate.
So I was explaining you about the 2004 tsunami event. Actually, during that period, I went there after 3 to 4 months, and I have recorded many ground deformation movements. But when there is a submarine earthquake, it creates a huge wave. But that low amplitude, maybe a few feet amplitude wave, that actually travels with a tremendous speed, maybe around 900 kilometers per hour speed, to all the sites in the oceans. And that when it hits to the shore, that will create the tsunami. Okay, so when the thick pile of water, which is around 4 kilometers of water, which actually moved with this wave. And when it hits to the shoreline, where the thickness of the water or depth of the water is very low, so that the wave breaks and it actually engulfs entire shore. So that is called tsunami.
Thank you, sir. Thank you, sir.
Just a minute.
And thanks for a wonderful lecture, sir. Wonderful lecture, sir.
Sir, now we would like to present a vote. We would like to present you a vote of thanks. For that, now I invite one of our research fellow and PhD scholar at Department of Physics, Ms. Hardika Goswami. Just a minute. Yes, please.
Good morning, all. Hello, can you hear me?
Yes.
Yes, continue.
Honorable Vice Chancellor, respected Pro Vice Chancellor, and today is our special guest, Professor Pratap C. Chauhan, sir, Professor Pankaj Joshi, sir, Professor Pankaj Gajjar, sir, Dr. Mehul Rupani, sir, Professor Mihi Joshi, sir, Professor Hiren Joshi, sir, Professor Nayan Jain, sir, and all participants. It is my privilege to have been asked to propose a vote of thanks on this occasion. Myself, Hardika Goswami, on behalf of Anusandhan webinar on research methodology and frontiers in science, jointly organized by Department of Physics, Saurashtra University, Rajkot, Gujarat Science Academy, and Essencetech, entire organizing team, and my own behalf, extend to a very hearty vote of thanks to all. A big thank you to Professor Dr. Mahesh Thakkar, sir, for gracing your important work and sharing with us your findings and opinions today. I must mention my sense of appreciation to sir for giving an excellent coverage of Earth as a dynamic planet, as well some knowledgeable topics like atmospheric revolution, plate tectonics, as well the physics of earthquakes and so many more things. And thank you so much, sir. We are all inspired by your great words, sir. And finally, I would like to extend my thanks to Professor Nikesh Shah, sir, Professor Nayan Jain, sir, Dr. Tushar Pandya, sir, and Mr. Chintan Panchasra, as well all the PhD scholars for their enormous cooperation in the organizing of this event. And thank you all attendees of this seminar. Thank you so much.
Thank you.